Hello there. Been a while since I've posted anything, so I thought I'd give you a little heads up on the next little project I got in the pipeline. It's based on the AD9850 DDS module. I thought it'd be interesting to throw together one of those little 0 to 30 or 0 to 40 megahertz DDS frequency generators, and that might be useful around the place. So I gathered up all the parts to put one together. Of course, DDS frequency generator, a display, which just is a normal bus interface, blue backlight, transparency mode, LCD display, the standard old 4470 some based one that you can get for $4 or $5 at most online retailers and stuff. Got a couple of them while I'm at it because I have another idea back in my head. And rotary encoder with momentary push button. I actually got a whole pack of the things. Always useful to have around. Ran out of them, so got a few more. And the brains of the unit. I could go with some modern fancy PIC or a microcontroller. But no, I don't go that way. I dug up the old 8048. First I made sure that the tuning word I needed to calculate for the DDS module could be done with an 8048, and it can, as if this wasn't going to work, I'd went up to an 8051 or probably a PIC or something newer, but no, perfectly doable with an 8048. So the equipment for the board, I've already kind of got it laid out. Socket for the 8048, socket for the EPROM, the address decoder, the address latch, and some glue logic to change the bus logic levels and modes to be able to drive the LCD. Because, as everybody knows, this is based on the 6800 Motorola parallel data bus with the combined read-write and the enable input, and Motorola 9 Intel-based processors use the separate read and write, so I have to do a little logic conversion and address conversion to directly hook this to the address bus. Otherwise, I've got to use the in-out ports like a lot of people like doing, but if I'm going to do this, do it right, I'm going to have it hooked to directly to the normal address bus. Same with the AD9850 will also be tied directly into the data bus. So that's pretty much a full wrap. I've already got the program pretty much roughed out in the stage where I'm ready to burn it to EPROM. All I've got to do now is get all the components soldered on the board and wire up the data bus and stuff, and it'll be ready for first testing of the program. All in all, the program for basic DDS functionality with a program that will calculate the tuning word loaded into the DDS module and display the frequency on here came out to 435 bytes total compiled size, so plenty of extra room to work with and totally unused ports on the 8048. So there's more possibilities I could do. I was thinking about a switched attenuator network, so I could control the output of the AD9850 to the output port by just using 10, 20, and 30 dB stepped attenuators or switched attenuators that could be controlled with the unused output ports, and of course display the value on the display. But I'll do that possibly after I get the basic DDS unit working. That's the reason I left everything socketed, so I could possibly do upgrades like that if I think they're necessary. And the only other part I haven't roughed out yet is the wideband amplifier. Since I don't want to hook the output of the DDS unit directly to the output pin, for the sake that something might be hooked to the output accidentally and destroy the DDS unit, I'm going to put in a wideband amplifier after this on the board to drive the output terminal or output jack, and it would be designed so it would be halfway tolerant to accidental voltage surges on the input. It'll have a protection network of some form on it. So that is a basic overview of the project. I'm getting ready to start assembling in my spare time, so take care, take it easy.